It's time. All right then. Good afternoon and welcome to the afternoon session of the October meeting of the Silicon Valley 4th group. And I won't take a, normally I'd be sitting out there, firing up my browser on my cell phone to see if the stream is going out. We're just going to have to take Dennis's word for it. Occasionally I like to say, gee, welcome. Welcome to those of you who are joining us on the internet. I'd like to say a few thank yous. I'd like to say thank you to the Stanford host, Dave Jaffe, for arranging for the room. We're very grateful for these facilities. This should not be taken as any kind of an endorsement on the part of Stanford for SVFIG or Forth or any of us ne'er-do-wells. I'd like to say thank you to Dennis Rufer, the Web Weenie stream host guy. I don't know what's your job title now? Cameraman. Okay. There you go. Webcaster.
No, I'm not casting anything. That's Google.
Okay. It's Google's fault. But speaking of that, I'd like to thank our chairman of our T-shirt committee. For those of you who like the T-shirts, you can chairman for life. I don't know. It was a benign coup, I think. The old chairman moved to Switzerland or something. Anyway, if you need a T-shirt, and you do need a T-shirt, send email to Brad or come to Fourth Day. We take all sizes per the meeting announcement or the schedule announcement. Has the list of approved SVFIG T-shirt sizes. If you act now, you're pretty much assured that what you want will be in stock. Hopefully we'll sell out and be able to tell all you ne'er-do-wells that didn't respond in time, you're out of luck. I'd like to thank George Perry, the chairman for life of SVFIG and keeper of the email lists, for which I am very grateful. How many of you are not on the email list at this time? If you're not on the email list, see George at the break. He will get you on the email list unless you've got some goofy, communist email provider. We don't cotton to know.
I have free invites to Gmail.
You
remember when Gmail was new?
When Gmail was new.
Invites left on your Gmail. So anybody who wants a Gmail account, I know somebody at Google.
Yeah, that's when it was first getting started. They would read your email and append little advertisements to it and stuff.
No, that was Yahoo. Yahoo would spam your email. At the end,
Yahoo would add some content.
Yahoo mail has rules and blah, blah, blah. Gmail never really put, I don't recall it ever appending stuff on my mail.
All right. I don't know. I don't use Gmail that much. But what I like these days is when you shop for something, you look, you do a search for some particular widget or wrench or maritime prophylactic dispenser or something.
Yes.
And for the next 3 or 4 years, you keep getting little pop-up ads with little pictures of little maritime prophylactic dispensers. And as it turns out, that's more of a thing that you do where you say to those guys, okay, no sure leave for you. That's the prophylaxis in the maritime domain. But suddenly you're getting these pictures of things and it's like, okay, they read my content, but they read my search. and they're providing, answers to questions that I asked 2 weeks ago or a month ago or a year ago.
Or you're getting more and more ads. You're getting more and more ads for the item you looked up, bought, and then that's over. But now for the next 6 months, you'll be getting ads for that same item.
Yes, that's what I was saying.
Brad, can we click on it and say, I'm sick of this now?
No, I think that the key to this, though, is to browse anonymously, and then you won't be getting these ads for stuff.
To answer George's question, yes, you can. There's a little arrow that's real tiny up in the upper right-hand corner. If you click on that, it usually brings down a drop-down menu, and one of the options is, this ad is not relevant to me. And you can click on that.
But that only applies to, that one particular category of ad, not ads in general. But the best example, the most hilarious example I've heard of this sort of technology is where this guy tells this story. He's a web podcaster, video blog guy, political pundit, and he talks about sitting in his kitchen with his wife, talking about fractional ownership aircraft. And he was basically saying, I don't like flying on commercial planes. I wonder how much it costs to get a piece of one of those private planes and fly around the country, living high on the hog. And I think he was talking about enlisting his wife as a stewardess in the old school sense of that whole concept. And sort of the next day, he started getting ads for fractional ownership airplanes, and apparently his cell phone was listening to him. And it wasn't, other than being on, it was streaming out what he was saying, and it would recognize apparently certain keywords and say, oh, we've got a customer here. We've got a live one. And there were a couple of apps that were notorious for doing this. I think that they've sort of become déclassé now, that you don't have to worry too much about that. Fortunately, my phone doesn't have room for too many apps, so I don't download too many apps. And the ones I have, whenever I plug my phone into my laptop to charge it, the file system of the phone pops up on the screen of my laptop, because that's the way I like it. And it says, okay, you've got 670 megabytes or some number out of 6 gigabytes. And I always look at that and I say, 6 gigabytes, what a huge amount of space. And what kind of stuff is there on there that's taken up, 80% of it? Explain that to me. Yes. And it keeps getting bigger, and it was 800 a couple of weeks ago, and then 700 and something, and then now it's 600 and something, and I think I deleted, I forget whether it was Yelp or Waze, one or the other. I deleted Waze, and now it's up, 700 again, but I'm pretty sure I'm going to have to, I forget what, Yelp or Waze, whatever one I didn't delete this past week, I'm going to have to delete another one. Let's talk about what we're going to listen to today's meeting. Does anybody have any rumors, gossip, announcements, slander, libel?
I'd just like to know if there's any specific recommendation for Forth on a Raspberry Pi. I say Raspberry Pi has some ports, but is there one I should look at in particular, or a couple?
There are 2 Forths that I've used on the Raspberry Pi. There is PIJ Forth OS, PIJ Forth OS, and that has a, you connect to it over the UART connection, and then there's RPI Forth, which is rather slow, but it works with the frame buffer, so you can use it over HDMI with a keyboard. And those are the 2 that I know of, but RPI Forth is rather slow, just warning you. But if you can find a way to make it faster, that'd be great.
What was the first one again?
Let me just look it up actually. It's PIJ Forth OS, I think it's.
So do these run under an operating system, or are they standalone-ish forths?
These are standalone bare metal forths.
So how do they know how to talk to all the peripherals?
How do they know how to talk to all the peripherals?
Like, let's say I wanted to put something out the Ethernet, or
They have drivers and so on. In the
are they
port.
black box drivers, or?
Well, there's the. I haven't used. The last Raspberry Pi I've used is the Raspberry Pi Model B revision 2, but that had a video core. I think it was 4. I think.
Yeah.
Video
Sort of interrupted you in the middle of answering Dave's question, I guess.
Yeah, there's the Video Core 4, which is like a GPU, and that connects to the ARM somehow, and then most of the stuff happens on the GPU apparently.
So that first fork you talked about, the DJ fork?
P-I-J, it's spelled P-I-J 4th OS.
IJ4OS.
Yeah.
There's a GitHub page on this.
That seems to be the most popular one. PIJ 4th OS.
Thank you.
Yep.
I believe there is a G-Forth built. You just want to run it with the OS as well.
Yeah, there's a G-Forth, sure.
If you just want a very generic command line for it.
I can run it over Linux, and there is also G-Forth libraries for Raspberry Pi that will allow you to use the GPIOs from G-Forth on the Raspberry Pi over Linux. So I forget what that was. I forget the repository for that, but it's out there on GitHub somewhere.
Yeah. Consider posting that as a question on the email list. During the week, I posted a question. Okay, so here I am with my Windows laptop, and I want to write a short program to read and write to a serial port and read out my thermometer and stream that out. And so I can be in one room reading out the remote display of the monitoring transmitter, and I could have my thermometer next to my oven, next to my laptop, and plug in the serial ports and read them out, and maybe start up a Hangout and look at these two temperatures and compare them and be in two places at once. So if you're following that on the email list, if you care to contribute, I'd be pleased to hear it. There have been some interesting comments thus far. Sam went off on a little tangent about FTDI chips. It was the darndest thing when I was actually looking for a serial cable, and it turns out that there are purpose-designed cables that will plug into the USB on your phone, telephone to RS-232.
Yes, that's very true, because now PCs do not have serial ports.
Yes, and my phone, I guess long ago there were phones that actually had RS-232 ports. It was the darndest thing. And apparently they've all gone away, except for I guess there are some modules.
They have not gone away. Serial ports are still in probably most devices, but they do not make the ports accessible.
Oh, there are little pads on the board.
There are pads on the board.
Oh, okay.
And
Deja vu.
They are no longer, certainly no longer running at 12 volts. Most likely they're running at 3 volts.
Yeah.
And even less. The fourth chip, the FA chip, runs at 1.8 volts. All of these still exist. They're just buried. Because nobody has a serial port anymore, and what do you want to talk to a council for? Yeah. And there's no security when you go on that level anyways.
Security.
There's no
Keep
security.
up with Mark. Yeah, yeah.
But at least the serial port, I can write a driver for it in assembly language, and it only takes, a few hours. But,
Assembly language?
yep, you've heard of that?
Now remember, assembly language is only for the more manly programmer. One of the ways you can test it, you have to have a metallurgical assay of your testicles to see how much brass is in it before you can do assembly language programming.
It reminds me of my youth. There used to be this poster, and I think one of the things about real programmers get up every morning and toggle in Unix from memory.
No, only the bootloader.
Yeah, it's
Only the bootloader.
8 bytes for the bootloader.
Yeah. Nothing more.
Yeah, 8 bytes and then get
If you're using an IBM mainframe.
No.
Well,
Oh, even worse.
I remember ODB on the console on a LSI 11. You type 7 characters, an octal address and G, and it would start up the EEPROM
Yes.
bootloader.
You brought up my next question. I have a Kromemco C10 I'm willing to give away.
Oh.
That's another thing. If nobody bites on it here, you might want to consider going to the email list and making it available to all comers.
A Kromemco.
Kromemco C10. It was the first small Z80 monitor. Have 2 5¼ floppies and 1 8-inch floppy. I love showing the 8-inch floppy.
Yeah,
It looks so
8-inch
weird. But I got 2 boxes of books. I used to be the president here of the local club, and I love my C10 Kromemco, but it got obsoleted really quick. Well, I bought it in '83.
Wow.
I had one also. Yeah, with the 8-inch floppy drive that had the voice coil actuator.
Versailles.
Yeah, what?
Versailles.
Yeah, Versailles
Oh, okay.
actuator. Yeah, I mean, it was about 120 milliseconds average access time. But then it took another 120 milliseconds for the disk to rotate around.
It's either a shoe drive or a tandem, because I got another spare drive for it.
All right. So the next order of business is a short discussion of the book of the month.
Kind of. It's like
You can just wave it around, and tell folks about it briefly.
fourth package manager was the.
Look here, put this on, stand in the front of the room, look goofy, while Sam makes his way to the front with his laptop and plugs into the projector.
So I had prepared a talk about, front of the room, about a fourth package manager. I don't know whether that was what was on the schedule, but put it on the list.
Yeah, it's just a short blurb about is there a book of the month?
Yes, and I have.
Why don't you tell us what that is, and then go on to tell us what your talk is going to be, and by then Sam will be in the front of the room.
All right. Just need to turn this on.
Looks like Sam's still working on his talk. So.
Oh, okay.
I'm just fleshing it out.
Is there space for my talk, or should I just keep it to the book? Okay.
You're technically a minute early. Go ahead.
Minute early, okay.
One more thing.
Yeah.
I wanted to say, if you're thinking about presenting at Fourth Day, which is the 3rd week of November, John, I would be grateful if you would communicate with me forthwith. And while you're doing that, you might want to drop me a line and tell me that you're not on the email list if you're not on the mailing list to getting all our exciting discourse. So keep that in mind. Let me know what your 4th day talk is going to be. Sooner is better. Speak on 4th day.
Maybe I can present the insight of ESP.
That'd be like way cool.
Yeah, that would be cool.
I tell you what, could you drop me an email with a title for your talk? And we'll get you on the schedule.
All right, so I have been thinking about doing a 4th package manager because well, there is one 4th package manager out there, but so basically I was thinking. Let's start with this. So I was thinking I needed a 4th package manager, and I didn't want to have additional words. Yeah.
Understand that this is the book of the month, not your talk. Your
Oh.
talk is going to be in the random access part, and Sam is scheduled to present. Right.
Oh, okay.
So we just wanted a couple of minutes, wave the book of the month around, say, okay, this is the book of the month this month.
Okay.
And if there's still no sign of Sam.
Sam is making his way to the front. He's just doing it slowly. With due deliberation.
Okay, so 4th for the Atari. Can you see, is it on the camera?
A little bit higher.
A little bit higher?
Yeah, there.
Okay, so this one, famous for its cover. And yeah, it's also a good book. It has... and yeah, it's... I haven't actually... I started reading it, but it's... yeah, it has a lot of like low-level hardware stuff in here, and yeah, I'm actually not particularly familiar with it, but it's yeah, I think it's interesting even if you don't have the Atari and computer console. Talks about like how to write drivers for a joystick and so on, but yeah, and then also. Well, this is the other book I was about to talk about is sort of related to my talk. There's an article in here that was related to the talk, so I could, I guess, talk about it in tandem with my talk when I do that. If that works. All right. Thank you. Should I unplug? Yeah. Wait, I need to turn on the... Otherwise, I won't see anything when I need to enable that again. There we go. Otherwise, I'll be in the dark. Oh, the mic. There's the mic.
I think I'm technically a little bit early, but oh, cool. Hi, my name is Sam Falvo. I'm here to talk about a file system that I'm currently trying to design for the Kestrel, specifically the Kestrel 2DX. Basically, I'd like to take you back a little bit through its history and some of its inspirations. This talk was probably originally intended to be 15 to 20 minutes, and then I looked at the schedule and all of a sudden I had a full hour. So I'll try to be reasonably detailed, but not terribly boring to the greatest extent that I can. So the attributes of the file system, which I call Structured Layout 5, or SL5, you'll see it abbreviated. It's a fairly minimal file system. It's probably its closest contemporary equivalent is the file system that you'd find on, say, Atari 8-bit DOS or Commodore DOS machines. It has a single flat namespace, so there are no concept of directories or subdirectories. You just have the one namespace. You can have files that are up to, you can have file names that are up to 47 bytes long. And in terms of reservation of storage space on the media, you can have up to what's called 5 extents, where an extent is defined as a contiguous array of sectors. The inspiration for SL5 is predominantly sourced from IBM mainframes, specifically System 360, primarily because its implementation seems to be very simple, at least as far as enterprise class file systems go. So along those lines, a file can have a primary extent and up to 4 secondary extents. The primary extent is always allocated. So in a sense, you're kind of partitioning the disk a little bit. Basically, you're saying, oh, I'm creating, this file foo.txt, for example, and I know ahead of time that it's going to take up 16 sectors, and that would be your primary allocation. For files that you know or anticipate will grow, you can set a secondary extent size that will be allocated as they are needed. So basically, there's no concept of a zero-length file in this file system. So I think I will advance from there. So what is the mission? Why am I even doing this? Basically, the Kestrel 3 is a project that I'm working on. Will have many megabytes or at least hundreds of kilobytes of RAM available, certainly enough that you can have a proper hierarchical file system installed on it with a proper operating system, with proper libraries, and all the other modern day amenities that we're all used to. The Kestrel 2 is not so well equipped. It only has 32 kilobytes of usable memory, and that's if you instantiate it on a Digilant Nexus 2 or an FPGA board with a similarly powerful FPGA chip. If you try to synthesize a Kestrel 2 machine on an Altera or Jurassic DE1, for example, the FPGA is quite powerful, but it doesn't have as much memory on board that chip as the Spartan 3 series of chips do. It's the particular Cyclone 2 chip that they use on that card only has something like on the order of 24 kilobytes of memory. 16K of that is going to be used for the video display, which means that on a DE1 you would only have 8 kilobytes of usable space for memory. So as you can imagine, trying to get a co-resident application, BIOS, and operating system nucleus or kernel or whatever you want to call it into an AK chunk of memory is going to be nigh impossible. And I can actually say from experience with the earlier Kestrel 2 that it is impossible. So basically what I wanted to do was to make a file system that was simple enough that I could include support for it as an application library. So that is to say I would link the code statically in with the application so that if I could read or write to files, I only need to link in exactly what I need. And that's kind of what I'm trying to do here. So basically, the expectation of this file system is let me back up a little bit. The expectations of where this file system would be used is SD and MMC memory cards, basically, not magnetic media. Therefore, we have certain reliability assumptions that we can rely on. So going forward, we know that this file system needs to allow us to boot into a host operating system of our choice, whether that be a fourth language environment or whether that be something more command line driven, such as STS or whatever. It has to allow for reading and writing to files or reserve spaces on the file system, and it has to basically support us in invoking compilers, link editors, that sort of thing. Basically, if I were to wrap this up into one sentence, basically it is to make the Kestrel 2 as minimal as it is self-hosting. That is to say, I want to be able to write Kestrel 2 software on the Kestrel 2 itself. So some of the inspirations and influences, well, it's basically an inspiration followed by an influence. Commodore DOS is what you would find on, for example, the Commodore 1541 floppy disk unit, 1571, and 1581 in various versions. They are incredibly simple implementations of a file system. They also have a flat directory structure, although their file names are limited to 16 bytes. They have an incredibly simple assumption that all files are sequential. There is no random access to files, although with relative files you can kind of work around that. And to actually get true random access to data on that disk, you have to go below the file system implementation. You have to go below DOS. But basically, because the linkage of these sectors that comprise individual files are sequentially oriented, they took 2 bytes out of each sector to provide linkage to the next sector in the file. And as a result of that, each sector stores only 254 bytes of actual data, which means that in order to find the appropriate byte of data that you're interested in, you actually have to implement an honest-to-goodness division routine, which really stinks. If only they had found a way to work around that and we could just use bit shifts, but they did not do that. Again, the assumption was that everything was basically cassette tape. That disk was an emulation of that. But as I said, relative files are a workaround for that. They're named after relative record databases that you access in COBOL. I have a brief paragraph here describing at a high level what they are. I won't go too much into them here, but they do add a couple layers of extra complexity. So the next source of inspiration and also influence is the IBM System 360 mainframe. This is kind of interesting. It also has a flat namespace, but even though it was introduced in 1964, it was kind of unique amongst its contemporaries because it allowed a massively huge namespace for files. You could have a 44-character long name, which back then was ginormous. And I think most of their contemporaries had varied between 5 and 12 characters. And in fact, that's where the word fourth comes from. Is when Chuck Moore was making the first version of Forth as we know it, he didn't have enough space in the file name to call it anything else. And so basically you had, the reason why they use 44 characters though is so that you could end up with a hierarchical naming system. So this is basically the computing industry's first attempt at organizing things hierarchically. Eventually, with Unix, that would end up being a true tree of directories. But at least here we see something very similar to like this file name here, A131072, that would be like your user identifier. You'd belong to the sales group and engineering subgroup. You'd be working on a content management system. And with respect to that, this would be in a library of assembly language source code. So that's kind of how you would write a typical file name for an IBM System 360 mainframe. Interestingly enough, this convention, besides the 8-bit byte and paging and all sorts of other things that mainframes have given us, this file naming convention actually gave birth, as far as I'm aware at least, to the concept of file extensions. Because typically what you would do is you would have, A131072.sales.eng.cms.asmlib, that would be your source code, and then you had to have .objlib, which would be your object files, and then you would have a bunch of other things. So basically, we already see the structure of, your project name dot some type forming in the use of the file system here. Even though that was never IBM's actual intent, that just kind of happened. So basically, I'm actually in a very similar situation with the Kestrel 2 that IBM was with the System 360, which is another reason why I look to this for inspiration. And that is base model IBM mainframes often were sold with 8 kilobytes of memory, maybe 16 if you're lucky. So as you can imagine, having an operating system co-resident with your application really was tough. I don't think that it was impossible at the time because their instruction encoding was a lot denser than the RISC-V is, but it certainly put a lot of challenges on. And I think there was a lot of swapping in and out. So much so, in fact, that major components of what we would consider to be part of an operating system today were written as assembly language macro libraries. They were not actually part of the kernel, for example. So the nice thing about this is that all the details of how things were stored on disk are documented because you want maximum compatibility against not only your applications, but also against different operating systems as well. So there's that. But it did have a couple of complexity issues. For instance, it arbitrarily limited that 44-character namespace to a hierarchical collection of 8-character qualifiers is what they called it. Today we would call them extensions, but back then they were called qualifiers. And they always had to start with an alphabetic character. They could never exceed 8 characters, and they can never be 0 characters in length, which means you can never have 2 dots adjacent to each other in a file name. Meanwhile, to actually find a file, all you did was a blind 44-byte comparison. It wasn't, there was no technical reason why you couldn't name your files pretty much anything you wanted within that 44-byte space. So that brings us to SL5, which is my file system for the Kestrel 2. It's basically, I basically took a lot of inspiration from System 360's filing system, and I basically just narrowed down all the concepts to the bare minimum. What is the simplest possible file system that I could write that would allow the system to boot up and to actually work like what someone would expect today? And there were a couple of other inspirations as well, but basically what it boils down to is I've got a handful of sectors here, collectively about 16 kilobytes worth for storing an operating system's bootstrap. Then I have some number of sectors contiguous for what's called the VTOC, or volume table of contents. That's where all your directory entries are stored. And then immediately after the VTOC, it's all free space, or whatever space is allocated for your files. And that's basically it. If you can imagine in Forth, you would use blocks, and you would have, one of the recommendations that Leo Brody makes in starting Forth is to have a load screen. So you want an application, you name it, you have a colon definition, I don't know, colon spreadsheet 11 load or whatever, right? So when you actually type spreadsheet and it loads block 11, you look at block 11 and you see things like user interface 1822 through, for example, right? So that's kind of what this VTalk is doing. This VTalk serves that purpose of the blocks that belong to this particular named file start here and there, starts here, ends there, and so on and so forth. In fact, anytime that you use the word through in forth, you're technically using an extent. Because that is the definition of an extent, is a contiguous sequence of sectors or blocks. Now, there are some rules that need to that I define here. One is SL5 nowadays, as distinct from when I first wrote it, you need a volume label. This basically names the disk or the media that you have this format on. And the reason you need that is because I use some of the previously unused bytes in that directory entry for storing things like this is where the free space list starts, or this is how many sectors are available in the full volume. $IPL is a mapping of the boot blocks, sectors 0 and 1 typically. $SYS, that is your system bootloader typically, or it could also be the kernel of the operating system if it happens to be small enough to fit. But the most important one, though, by far, is $dir, because that is the file that maps the VTalk itself. Without these directory entries, those sectors would technically be free. And of course, we don't want anything overwriting our boot blocks or our directory entries. So we pre-allocate these directory entries to prevent that from happening. For everything else, though, it's pretty much just an array of data structures that are 64 bytes in size. 48 of those is reserved for the label for that name, for that particular file. And that basically is 1 byte of length information followed by 47 bytes of text. The remaining 16 bytes contains information such as where the stuff is located on disk, as well as what kind of information it is. So we have several different types. We have the obvious empty slot. That is to say that this slot in the VTalk is available for use. We also have, as I mentioned before, the volume label. So we see here we've got a sector of the first node in the free list that allows us to allocate new space effectively. Last sector of the volume as a whole, so that tells us how big the volume is. And we've got plenty of space left over for additional information if necessary as well. Each of these pointers, by the way, are 16 bits wide, so technically this only allows up to 32 megabytes of storage in a volume. But that is a deliberate design decision on my part, because the bigger you make your structures, the more complicated it kind of becomes, because you're dealing with more bytes to move back and forth. Let's see here. So this is the next one. This one is actually the actual file itself. So basically we've got a name between 0 and 47 bytes in length. The VTalk entry type is 1. The rest of that field is 0 for future compatibility. But you'll see here we have a starting sector of the primary extent, and then the last sector of the primary extent. That determines those two words, half words actually, they're 16 bits. Those two integers basically determines the length of the first extent of the file, and it could very easily be the entire length of that storage volume if you want it to be. You also have a secondary extent length in sectors. 0 means that you cannot grow the file. So for example, I cannot grow the directory, or I cannot grow the boot sectors. That doesn't make any sense. But then we have here pointers, if you will. These integers identify the starts of secondary extents if they're allocated. So if non-zero, then they refer to the start of a secondary extent. All of these extents all share the same length, the same secondary length. So basically things will grow in either smaller or larger chunks if you want it to be. And that's basically it. I basically described to you everything as far as how to implement an SL5 file system. And this simplicity is exactly what I'm going after. I've actually got some code. It's not complete yet, but it is quite reasonable. Oops. Let me go back here to tools. So I've got, so in this case, this code here is the format tool. So this is basically a little program that I wrote. Here I draw like a menu on the screen. I'll illustrate this shortly if you like. But basically we've got some like a reiteration of what I just went over. And then all of this code basically zeroes out and predefines and allocates. So like this word allocate here, for example, it's very fairly sophisticated. It finds an empty VTalk entry and then populates it with the file, and I'll show you how that's used down below. Basically, when you actually instruct it to format, the first thing that it does is it checks to see if you've actually confirmed the format, because you don't want to accidentally, blow something away. We compute the number of sectors, the number of VTalk entries. We determine whether or not it's a quick format versus a slow format. Although I do all my stuff on the Unix file system, so I just do slow for everything. We do some basic input validation to make sure that you're not putting in, bogus information. We open the block file because I emulate disk access using blocks. And then what I do is, the first thing I do is I zero the disk, or I call it the disk, but it's actually media. I zero the media all the way up to the end of the VTalk. That's technically the quick format. If I don't want a quick format, I then zero the rest of the rest of the volume, basically. And that makes sure that I have a file on the Linux side that is the proper length. So I could do the Linux command ddif equals blah, 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 of equals /dev/mmc block 0. And that will copy an image file directly onto SD card. Here we actually pre-allocate some of the stuff in the VTalk. So basically we are relying, so the first thing we do is we create the volume label, then we reserve the boot information, and then we reserve the directories. So here you can see basically I'm allocating, this is a type 2 entry, these are all type 1s because they're proper files. And the primary start, primary end, that determines how big the file allocation is. And then secondary extent size, these are all set to 0 because they're not growable. But a more proper file, quote unquote, like if I were to use a text editor, that might use a growable file. And then basically from here, I calculate what would be the head of the free list. I update and I flush. And that's basically all there is to the format. This is, well, if I had a different, oh yeah, here we go, show line numbers. Right, so this is basically about 146 lines, including the user interface overhead, comments, blank lines, and that sort of thing. It's very, very simple. Compare this to something like Btrfs or ext4fs or something like XFS. Like you'll never find a simpler format. Yes?
How does this compare to the FAT file system?
This is simpler than FAT.
Yeah, it looks much simpler, but yeah, it's often, they use FAT a lot in embedded systems, so. But is this supported by Linux at all?
No. No, all of this is custom. So the question was, how does this compare against FAT? This is much simpler than FAT. And is this supported in Linux? And the answer is no. nothing prevents it from being supported in Linux, but I just you could probably use Fuse with this, yeah, at some level. So I am looking now for, where am I? Go files. So then the actual file system itself, I'm just going to show line numbers right away. So this is the actual file system proper. Starts out with a bunch of definitions, conveniences. I have some variables that describes the currently open file, quote unquote, because I have yet to write the actual open command. So you have to emulate this yourself, but once you do, it works just fine. We have some public interfaces. These variables take the typical input parameters that you would from a Unix read or write command. So you have a buffer pointer and length, you have a seek offset, and on output you have an error and an actual number of bytes transferred. So it's actually, in that sense, it's very Unix-like. The big difference is that all reads and writes have an implied seek, just like in 9p actually. And this actually simplifies things quite a bit. We also maintain some internal state intended to keep track of where to find our data within a bunch of extents. So this code, this word extent, for example, basically it starts out with the primary extent, and if our desired seek fits within that extent, then we just exit. We already know that we're at that in the primary. Otherwise, we know that we have to have some kind of secondary extent. So the first thing we do is we check to see, is the file fixed in length? That is to say, can it have any secondary extents at all? If not, then we return a length error, which is, too small. If we have exceeded the number of secondary extents that a file can support, we also return that the file is too small. Because at this point, you're seeking well beyond what is currently allocated to the file. Otherwise, we just advance to the next secondary candidate, and if that slot happens to be empty, then we know we've already reached the end of the file, and that also returns a too small error. And then we just keep looping on this. And this maybe 20-ish lines of code is basically what you need to enumerate any random access within a file. And all of this happens in RAM, assuming that your block interface does proper caching. So this all happens blink of the eye, linkety split. There's really no I/O overhead to doing this. Now, reading and writing basically has the same fundamental structure, which you can see here. Like if we read or write, all we're doing is we're setting a callback in a sense, and we're just transferring a single record, which is however many bytes that you specify. So the way that this works is we start by seeking out the starting extent. We then read to the end of that extent, and then we advance to the next extent and read to the end of that extent, or to however many bytes are left as appropriate. And of course, along the way, we maintain enough accounting information to record how many bytes we've actually transferred, that sort of thing. And as you can see, it's a fairly small amount of code. This is code which is responsible for reserving space. Now, eventually, one of the things about the write function there is that you can write to any portion of a file that has already been allocated, either in primary or secondary extent, but it cannot allocate new extents on its own. And in order to do that, you have to be able to reserve space from the disk. So I'm actually starting to write that code now. This word, reserve, is basically malloc for the disk. It will allocate a portion from the list of free sectors, update that list, and then it will return that list to the caller. It'll also update the volume, the VTalk as well, to properly account for that. Extend depends on the use of reserve, which you can see here. But basically, this is the next layer up, so to speak. Extend is responsible for actually extending a file by one secondary extent, if it even can. And as you can see, that's also a fairly small amount of code. So basically, to implement write that is general enough that it will automatically extend a file, basically I have to write new, like maybe 3 lines of code here that basically tries the old definition of write. If it fails, we call extend. If that fails, then we actually do the fail. Otherwise, we call write again, because we know that it'll succeed that second time. And that's it. So that's basically like maybe one new word. Typically, I think maybe 3 lines of code maximum. And that will flesh out the read and write functionality as a Unix programmer would understand them. After that, the only code that would need to be written would be open and close. And I think it's done at that point. I think that would qualify as being a high-level file system interface. Now, the nice thing is this runs under Linux. I can write applications in Gforth. In fact, all of this runs in Gforth. This whole chunk of code takes about 7 kilobytes of dictionary space in Gforth, including the long word names that I have. So on something that takes up on something with like a 64 kilobyte dictionary where you have only 16-bit indices to words, this would probably take up closer to 2 kilobytes, maybe 3 if you're lucky. So that's SL5. Basically, again, I'm hoping that this will be used. Oh, let me show you the format tool. So basically, at some point, again, more inspiration from IBM mainframes. Basically, this is a panel-based interface. FSE stands for full screen editor, and /L means it's running on Linux. And basically, but basically, this is intended to eventually be a menu of options. For example, format volume, obviously, but also give me a directory listing, and also, invoking text editor, that sort of thing, so that I can actually edit files on the SL5 volume itself. So here I'll select to format a volume. So we end up with this type of interface. Again, 3270 users would feel right at home with this. So I have I'm referencing a temporary file here. This is saying that it's about 10 megabytes in size, right? So 20,480 512-byte sectors. The VTalk itself starts at sector 32, goes for 160 entries. So basically, by the time I'm done formatting this, I will be able to support up to 160 files on the volume. I can change this, of course. I could change this to 999, for example. That will create 999 entries in the VTalk. This is the volume name. I don't actually use the name field. I just use the other fields for maintenance. But realistically speaking, if you have multiple different storage volumes, you would want to use different or more descriptive names. The only VTalk field that is, we would set a / there, for example, if we were formatting quick. Otherwise, we want to keep that blank. That way it's a slow format. And then to actually commence the format, we would want to say confirm there. That way there we know that what we're actually getting into. Oh, I must have changed something because now it died. But I think Okay, come on, work with me here. ls-lh. There we go. Oh, I had one there that was 32 megs already. Okay, not a big deal. But if we do a hex dump on that, for example, so that's kind of what the VTalk entry looks like. It's a bunch of zeros for the most part with text. This is incredibly simple. You can basically you can allocate if you wanted to. You could use just a simple hex editor and allocate files, populate stuff. That's how simple this is, and that is by design. But again, the mission profile for this file system is not to be reliable. It is not to be you know, the next great file system or whatever. It's not even intended to support databases per se. It's just to get the Kestrel 2 to bootstrap with the smallest amount of code that I need to write to do so. And I think this is a pretty good solution for that. I can also go 32-bit wide pointers if I wanted to support terabyte-sized drives, but I don't see any particular value in doing that. Basically, if you've got a hard drive that's terabytes in size, you probably want a little bit more reliability than what this file structure will give you. Yes?
Somebody behind me. What do you mean by reliability in this case? Like
So,
leveling or?
not just wear leveling, although that's important for solid state media, but also bit rot. So for example, magnetic media, eventually two domains on a disk will eventually merge if they're opposing magnetic poles, given enough time. And so you end up with the occasional single bit error. There are some file systems that are much more robust against this than, say, this. Right. So this simple of a layout works nicely for solid state devices, but you know, like I said, I'm using fourth blocks to emulate that, and that has spinning metal in it for storage. So conceptually, you know, someone could use this to store on disk. Right. That would be at the block layer. Yeah. Yep. Any other questions? So fragmentation is rarely an issue with this, primarily because your files typically are pre-allocated. So for instance, if I open a new, so there's no concept of a zero length file on this. In fact, there's no concept of any file length less than one sector on this. So if I were to create a file with just the letter A in it, it would still be a one sector long file, for example. So the directory entry is only aware of sectors, not individual bytes. That being said, you can have up to 5 extents total, right? So you have one large, possibly, extent for your data, and then you can have 4 smaller extensions attached to that. So there is some amount of fragmentation, but it's very limited. And in practice, even on magnetic media, on practice, having only 5 extents would only add noise to access times. Keep in mind that IBM's approach is very similar, and they were developed for both drum machines and disks. And in fact, to this day, their file systems still use the same layout. So it's and IBM is you know, their mainframes are very well known for extremely high performance file I/O. So I don't think fragmentation is an issue on this. Yeah. Also, all your modern file systems like Btrfs, ext4, etc., like all of them, pretty much go the route of extents nowadays as well. The only difference is that it's hidden from you. Yeah. All right. If there are no other questions, I'm at 2:05. I think we're into our break. I think.
We're going to listen to me blather for a couple minutes and take a break. I think the break was scheduled for 2:30. But we're going to invoke the organized, maybe too strong a word. Organization may be too strong a word rule. And the break may be a little early this time. A while back, we were looking at this thing, which will come up on the screen momentarily. Or not. Oh, okay. This is a puzzle. This is a map of the Middle East. Many of us don't know which countries are where. I guess most recently Niger, or Niger, if you prefer, was in the news. So there it is. Let's see if we can get this to reload just for fun. So you start off this game. It looks like this. And then you have to figure out, well, let's see, Pakistan. Now, it was kind of interesting. I guess I had a country left over while I was not listening to Sam as I should have been. I ran across this and filled it in. Anybody know where Bahrain is? Good. Me neither. All right. Say again? No, I meant where it is on the map. It looked like I had them all filled in, and Bahrain wasn't populated. So it just goes to show you. Yeah, I was going to say, I thought better of it. So the other thing I wanted to show you, while I was showing you interesting things on the web. Well, shoot. Trying to train Google to find stuff that I'm of the opinion I know where it is, but sometimes I will ask people, well, do you know where something is? Not because I don't know, but because I think they should know. That was the question I was going to bring up. How much longer to fourth day, you ask? Or actually, Dave asked, but that was the question I was going to bring up. And I was actually kind of startled, being the actual fourth day program chairman. This is a number that brings terror to my heart, because it's 20 days. It's less than 3 weeks. And let me tell you, that's a scary number. So let me reemphasize that if you're going to present on fourth day, especially you weenies that are out there in the internet, I think you should send me an email now. It's the last minute. It really is. I'd like to fill up the agenda. John went to the bathroom, but he's going to present. Sam Sub 1, Sam Prime, and you want to count as one? That was the question. And this Sam's going to present. You're up for a short talk. This is going to be fourth that you're going to talk about. All right. Sam Falvo has committed to sending me an email with his topic. Preferably send it to the email list, the SVFIG email list. That way everybody will know what your talk is. And if I can't find it later on, I have an easy way to go look for it. All right. With that said, we're going to take a short break. And then Andreas said he wanted to give a talk. So generally for these Saturday meetings, like a week before the meeting, if you can let me know that you're going to give a talk, that'd be great. Not that I'm not grateful for the content, even if it's the last minute. If it's the day of the meeting, we'll try and squeeze you in. Today, we don't have a lot of stuff to do. We've got the cleverly labeled random access. I think I had threaded Grammar Girl videos. I like Grammar Girl. If you haven't listened to her podcast, well, you've missed her podcast. But I recommend it to you. And with that, we'll join you again in, I don't know, 10 or 20 minutes. We were just taking your name in vain, John Harbold. We're saying you're going to present on fourth day. And for that, I'm grateful.
Yes, it will be about running P threads under G-Forth.
Ooh, that sounds interesting.
Yes.
In my thank yous this morning, I probably forgot a couple of people, but I did want to mention Andreas Wagner, the presenter that's going to present after the break, is the fourth archivist and librarian, and he wants to sell you some books. And if you don't know about that, send email to the email list. If you're not on the email list, send email to me, or if you know his address, George Perry. And with that, it's break time.
And it would have to be very.
1 minute warning.
Very grainy. Yeah, almost.
So we were talking about standards, and I was thinking, that reminds me of the stupid label guy. So this is copyrighted material, so it doesn't really belong on the YouTube video, but not to worry.
Apparently you can share it on multiple platforms.
Well, apparently so. So while I was looking for the stupid label guy, I ran across this other good Dilbert cartoon, and apparently they were going to prove the industrial sludge is safe by forcing an intern to drink a glass of it. That reminds me of a story. There was this guy, he had invented Simple Green in his garage, and he went around to all of these places to try and get this manufactured to sell. And his big shtick would be, he would stand up on the boardroom table, take a glass of Simple Green, and drink it. Because this stuff is, like, non-toxic. So, the point of all of this was to say, gee, the neatest thing since sliced bread, one of the great non-Nobel Prize winning technological innovations in today's world, the search engine on the Dilbert.com website. So if you've ever thought, there was a Dilbert cartoon about that, you could go and look at it, but I recommend that you not put Dilbert cartoons in your presentations unless you're going to pay for the copyright or the use thereof.
Remember, Scott Adams? Yeah, he no longer works. All he does is makes it work. Yeah, makes cartoons. Yeah, he probably make more money making cartoons than and actually, was he working at TNT?
Well, yeah, at one time early on in the idea of his comic strip, he worked for AT&T, I believe.
And
but
then when he got a new boss, his boss said, "You must go now."
And he said, yeah, I'm making enough money. Yeah. There was another guy I heard of. He was a technician at a lab in Colorado, university lab, and he had a backhoe, combination backhoe front loader deal. And he was actually making more money excavating than he was as his tech job. So he quit the tech job and moved on to a retirement as a full-time backhoe operator.
Well, here in Silicon Valley, many of us in Silicon Valley have been millionaires multiple times. We've never generally, that's on paper anyway. You're working for a little startup company, it becomes a $5 million company, and you've got 3% of the stock in it. Okay, well, that's fine, but it files for bankruptcy 2 years later when it, crashes.
Yeah, well, the value of the thing is what that thing will bring. I read that in a Heinlein novel. I'm inclined to believe it. Did I mention that Fourth Day is less than 3 weeks away? All right. Does anybody else have rumors, gossip, announcements? Okay.
Guys.
Hi, John.
Just so you guys know, the La Dia de los Muertos, California is going to be raising the gas tax 12 cents.
I thought there was
12 cents.
They qualify the ballot thing.
No.
No.
Going up 12 cents.
Well, what about the ballot thing?
What about it?
What about it?
Oh, I heard it qualified.
We vote on that.
Okay, well, if I qualified for the ballot, I would say, you wanna put this, you wanna suspend this until the election decides.
Yeah, good luck with that.
Maybe it doesn't work, yeah, I'm sorry.
If you buy gas, you can debate that with the guy that sells it to you.
Delusions of responsibility.
All right. On that cheerful note, I yield the floor. I'm going to go start up Google Maps and find out where Bahrain is.
Just, oh, here we go. It's primary. Is it working? No. There we go. Okay, so I have been thinking about language-specific package managers, and it's sort of the idea of a language-specific package manager is kind of controversial, but maybe there is some advantage to it because you can leverage some of the aspect of the language to improve dependency tracking or so on, but only if you leverage the language for that purpose. So in this package manager, it's a proposed package manager. I haven't written any code for it yet, but I wouldn't add any new words for this package manager. I would use existing words to operate on a networked dictionary with so instead of just memory addresses, I would also have network addresses for like a URL for a word for the purposes of package management. So you could use the word to print available words in the package repository, and you could do cfoo to print the source, c word name to print the source of the word, or sifting to find words. This comes from open firmware, these particular introspection words. Or you could use tick to get the address or URL of a word, and so on and so forth, and so on. And I would use a dictionary for package management as well. And for individual words, this is probably going to be controversial, but the creator of Erlang came up with this idea. I can't find the email thread where he proposed it, but I think it was the creator of Erlang. And he said, why not have a package manager for individual fourth words or individual Erlang functions? And I think it's sort of a radical idea, but I think it may work. I haven't tried it, but it may not be a bad idea actually. And it sounds a bit extreme, but words have dependencies. Words have a definition, and within that definition, it links to other words. And a word plus all its dependent words could be called a package of words. And that sounds a bit more reasonable, I think. But it has the fine granularity that Forth is known for, perhaps more than other languages, which are more revolve around libraries and large functions. Forth revolves around words, which are programs, essentially. So why not have the package manager revolve around individual words for our language? So the Forth dictionary is effectively an n-way OR expression. So if you match the first matching word is the one that's chosen for a given name. And when you're matching a word, you skip words that don't have that, if the word isn't matching, then you can just skip the rest of the word name and continue until you find a word or don't. And that's called hyperstatic scope. Effectively, it's the closest analogy to hyperstatic scope I could think of. And so the old versions of the words still work, even if they're shadowed. And this is sort of a goal of the Nix package manager. You just, like old versions will still work. There will be no breakage if you install something new. And I think, well, at least some fourthers embrace the idea of just liberally redefining words. And maybe not all. Some people like to add prefixes to their words or use word lists or so on. But personally, I like to just redefine words and have words have a different meaning in different contexts. It just keeps things more concise, and the hyperstatic scoping allows for that. And there's no breakage, just like with the Nix package manager. And you get that for free. So for versioning, sometimes you do need to know, like, what effect will this word, what effect will installing this package have on the dictionary. So I think somebody on Twitter mentioned, I think Sam Falvo knows who this was, but I don't remember. Peter who? Peter Hinton had the idea of using, rather than version numbers, considering API compatibility or API contracts. And so basically we want to think of what is the effect of adding words to the dictionary? What is effectively this dictionary stack effect of adding new words? And I'm still thinking about how that would work, but I guess it would have to do with the short circuiting of OR and like OR, logical OR short circuiting effectively. And another thing I don't like is marker and forget. So adding new packages to the dictionary is just adding on top of the dictionary. Every time I make a change, I just add new words to the top of the dictionary. That's the most user-friendly for me. The trouble is you fill up your flash space or fourth dictionary pretty quickly if you do it that way. So yeah, one idea I've been sort of trying to figure out how I might do it is to have dictionary compaction to remove words that are no longer used. But how to do that without fragmentation, I don't know really. So one thing you could do perhaps is have some sort of region-based memory allocation for different versions or something like that, but I'm not really sure how that would work. Just a proposal. But yeah, so redefining words. So then I had the thought, this is not really a complete solution, but you could only add words that differ, not in their name, but in their definition. So if you're compiling a word, in the definition is different, then you compile that word. If the definition is identical, you don't compile it. However, so yeah, you match the definition, not the name. If a definition already exists, you don't compile it. This way, you can clobber definitions with the same names, or if you want to escape the shadowing, you can create a new name. So personally, I think redefinitions should be about definitions, not the names. But I'll see how that turns out, how that pans out. And thank you. And any questions, comments? Safe. What was that? Oh.
It sounds an awful lot like save system.
Save sys. Yeah.
Yeah. Where you say, you created this, this executable.
Mm-hmm.
You say, okay, save system, and then it goes through, just grabs all the stuff. And I believe save system, if I'm not mistaken, can decapitate headers, if I'm not mistaken. Like
Yeah,
the
you could
name.
keep the headers separate from the dictionary if you want, some stuff like that.
Yeah. Is that? I mean, is that what it is?
Well, it's sort of like a networked dictionary where you can, yeah.
I'm sorry. Okay, so you're talking about distributed.
Or from maybe like a centralized repo, or maybe distributed, but
I see. Bring it in and load it.
you load definitions with a URL, you compile definitions from a URL, not from a
I see.
address or a
Okay.
URL.
So this is not like, this is getting stuff
Yeah.
to your dictionary, not making it executable.
Yeah.
Okay.
So like
I got it. Well, hey,
yeah.
I'm burned out as a
Anyway.
But yes, that's good because networking really hasn't been addressed with Forth.
Mm-hmm.
I mean, extensively.
This should work
it's
with.
all in its little processor, kind of stuff. But here, you're going, I'm going to use Forth to go out to the network and grab stuff. Wow, boy, you could even. You guys have heard of RPC, remote procedure call.
Mm-hmm.
I wonder if you could actually do something like that with Forth. That would be interesting.
I know that's possible. I think there was an application that Forth Inc. had made for Saudi Arabian airport that used RPC expressed as Forth words over high-speed serial links.
RPC might be a little stretch. Yeah. There were a couple applications of that. I worked on the express version of that, where we had remote terminals that would do graphics and full graphic interface over a serial terminal through Forth, with Forth words, passing Forth words back and forth.
Yeah.
And worked pretty nice. And this is better than that. Where you're going is good.
Thanks.
It's it's not applicable for a deeply embedded system.
This.
This.
Well, I guess you could. It doesn't necessarily need to be a network link. It could be a UART link. It could be a radio or a Bluetooth link.
Any
perhaps.
link you've got out of your system, correct? But
yeah.
Even if it's just a UART link, you still need to transfer code, so you've got to have some X modem or something like that.
Yeah.
You've got to have a transfer mechanism.
That's right. Yeah.
But yeah.
When you get like Nix style safety from adding new packages for free almost with hyperstatic scoping. So.
Now, you do, as we were commenting before your talk, you need a versioning system.
You think you need that? You're not feeling the redefinition, like the clobbering of names, or, I mean, it could turn out to be a mess, but
it could turn out to be a mess.
Yeah, perhaps, yeah.
And so you might want to have, and here's where you've got to. What you mentioned is that if you've got two words that are the same, made up of the same words,
yeah,
you don't load that new one, and you've got to have some way to identify that.
But there's the hyperstatic scoping, so the old versions. Oh, but if you add a new package on top of an old dictionary, then that's where you need the API contract.
Yeah.
Yeah.
Yeah, you've got a contract between words, and you've got to deal with that.
So the way something like Git deals with that, because Git doesn't work based on file names. It works on the concept of file content. And the way that it does that is with a Merkle tree, and that implies cryptographically hashing the content of the word or file or whatever, as distinct from naming the word or file, etc. So basically, the way to do this is you have to do a deep inspection of the Forth definition to be able to identify, the hash of this word is blah, 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 blah. My issue with doing this is now you have to deal with direct threaded, indirect threaded, subroutine threaded, is it token threaded, is it, string threaded, you have to find a way to abstract out the threading model so that when you look at the contents of the fourth definition that you're hashing, that it comes out the same, because my fourth might be a direct threaded interpreter, but his fourth might be subroutine threaded, and that change in the encoding will definitely result in a change in hash if it's done naively.
It's kind of like the difference between a static library versus a dynamic library. Whether you bring in the actual executable and put it into your system here, where you have you say you refer to another thing. That's what that kind of is coming across as, and that could be a problem because, again, you brought up versioning, Dennis, and I've run into that problem where the shared object libraries have different version numbers. They don't work.
Yeah, I was thinking of versioning from a change point of view, but Sam brought up the issue of what it's compatible with. Yes. Is another side of the versioning. Yes. And so you've got some metadata with each word.
Yeah, so I had this other idea regarding this API contracts that I did not put in here. It just have a 32 word, like a 32-bit cell, and each bit would be the and of of a word plus all within the and of a word and all of its if it's a 1, then it's compatible, and you'd and it with the parent of that.
I'm afraid you will run out of bits.
Yeah, I think a 32 bits wouldn't be enough. Yeah.
I would go to more of metadata concept.
Yeah.
That you've got a linked list of thingies that this is compatible with or version of.
Would you have more than 32 words in a definition? If you do, then you would need.
That's the other part that I was thinking of. The versioning is you've got a factoring problem.
Mm-hmm.
You can't know.
You need to graph isomorphism and
because
it gets hairy.
Factored differently.
Yeah. Yeah, factoring.
Yeah. but that implies a change in interface at some point, right? So that could qualify as a change in contract, and therefore your cryptographic hashes would be different. That's something that.
I mean, refactoring is by definition.
Things to consider.
Yeah, refactoring by definition is does not change the interface, but it does sort of in a way. At least in another part of the software.
It changes the underside, the back side of the interface, not the front side.
Yeah.
Yeah.
Yeah, and things food for thought. There is one thing from the Rochester fourth, kind of related to the use of or and as viewing the dictionary as parser combinators in a way, where matching a definition is a logical or and matching a word is a logical and. There's this article that I thought was kind of interesting in the Rochester, in this one here, and there's this concept of a whatever word, which has part of the name of the word is it's accommodated for in the account, but there's no the characters are not defined, so it's like a wild card within the word name, and you can use the contents of the wild card within the definition of the word. So that gives sort of some extra flexibility. I thought it was kind of related to that, but that was interesting. Side digression. Might be useful for package management, but I'm not sure how yet. Anyway, just some thoughts. Haven't written any code.
It's good that it's being thought about.
All right. Anything else? All right.
Cool. Excellent.
Thank you. Or is there anything?
Anybody want to blather? Or
Are we going to do anything else for the next hour? I was thinking we could pack
I
it
just
in
want
and
to say
bolt
some
the door.
stuff. Okay, thank you. All righty. What's I've been doing when what's his name here asked me what I was going to present at Fourth Day. Well, had because I have been working on getting G4 to run under an RTOS. Well, the RTOS I want to use almost is ready to be released because it has thread local storage in it. But I'm waiting for the whole thing because it also will have SMP, which I'd like to be able to use extensively. But I've been create GUIs using Glade and then write the callbacks in Forth. The only relation so I'll try through stuff that I did get working. I presented many moons ago having p-threads run under p-threads under G4, which does work, and I have all the function calls plus a few other scheduling kind of things, so that now literally you can write threaded Forth with p-threads, a well-known thing, which is really nice to be able to do. And I actually was able to have multiple threads of one word that a test program that I just passed in different data, and both of them run. Well, I had 4 of them running at the same time, and they're outputting their stuff, and it works. And this is nice because I probably should also in the future give a talk on how to do p-threads, because I noticed in my experience here in the Valley, not many places know how to do threads properly.
That explains the rise of evented architectures, actually.
I'm sorry.
Evented, so like things like Node.js and such, like all event-driven architectures.
Yeah.
They claim that the currently popular claim is it's more performant, it's uses fewer resources, which it kind of does, but the real explanation is no one really knows how to properly use threads because the Unix/POSIX environment does not properly support threads like, say, AmigaOS or OS2 does.
Right, yes. And also the other thing is, in these RTOSs, they now have a distinction between a thread and a task. Because you can have a task which is like in Linux land would be like a kernel task, and you have a thread which is like an application. So you can have several applications running p-threads, which can then use the tasking stuff internal to the operating system, which is also nice. And another thing I learned was that place where I'm working. How many here know about Thunderbolt? The bus. 1, 2, 3. Yeah, and it's neat because I found out that it's a combination of a DisplayPort and PCIe. And I'm going, wow, if I could get this G4 running under an RTEMS, that's the one I want to hopefully use. Maybe I can also be able to integrate Thunderbolt support, because a lot of these real-time operating systems, they also have USB. They got also these other interfaces that work, and I'm going, wow, you can literally make your own little gizmo if you want that has a USB or a Thunderbolt or an Ethernet or whatever.
it's great because the first thing I'm going to do is I'm going to make a USB hub that you can develop code on, a Forth based, and you can communicate. You just take your USB, the A, plug it into your computer, and you can have a TTY, a serial link between the two. That will be your terminal when we're OK comes out. And you'll also be able to debug interactively your tasks. Because remember, you have control of the inner loop. Inner loop, and I can say you can set the concept of a breakpoint is, in which you can say, like the third word in a word you're debugging. I want to put a breakpoint there, but I want it to break on when this thread is executing it. Okay, so and the other nice thing about it is I'm going to be using QEMU so that I can debug, on my PC, just to at least get the thing going. When it gets going enough, then I can say, okay, get like a Raspberry Pi, and then start doing USB development on it. But you have real time. That's the key. You get real time programming, means preemptive. Now we all know that Forth does support multitasking, but it's cooperative, and that's fine. But I'm a lazy programmer, and I want to concentrate on what my tasks have to do, not when I have to switch tasks. And also to make the system event driven, because polling will kill your performance. Okay, so I guess this is just because I have at work I have a tendency to get on my soapbox and harangue those knuckleheads there about how badly they've been doing thread programming. And the other one was the processor. They have a DSP chip that came with a real-time operating system, and they decided, no, we'll just write a simple loop. That it'll work. And you know what happens with polling loops over time. They tend to get really big. So you're going, oh, wow, performance is really slowing down. Well, why is that? Oh, yeah, faster processing. So I just go, I guess I must be speaking Swahili with a Scots brogue. That's why they're not understanding me. Okay, enough of my fire and brimstone. Anybody else want to, soak this little microphone with spit?
I could talk about parallel concatenation, if you have time for that.
Sure. Well, parallel concatenation?
Yeah. I saw an article on it recently. I thought about, I had, just a moment, just pull it up. Just pulling up the article. Yeah, I just need to find it first. Oh, here it is. Good. So, I was talking about this with George Perry this morning, and I thought it was pretty interesting because it really reduces the amount of, it's a way of really reducing the amount of stack manipulation that is necessary if you want to, if you don't want to inline all your operating words. Is it showing up? Oh. There we go. So somebody came up with this. I'll make it bigger. Oh, that's not working. Now? Okay, move the window. Yeah, so I saw this article searching around about concatenative languages. And basically, the idea in a nutshell is that you have
Please try
one more expansion. Okay.
maybe
Another. Is that better? Okay, you can read that. And so just very briefly, so if you have 2 plus 2 and or 2 times 2 and 3 times 3, and then you add the result. Often what you would do is do some stack juggling or insert these operators, interleave the operators with the literals. But this guy has another way. He has arities. The arities of the word must be known in advance. However, you can do things like you can have a syntax such as, where is it? Okay, so you could do, I'm just looking for it. Oh, right here. So 2 plus 2, or 2 times 2 and 3 times 3, and then you add the result would just look like that. And it has this parallel concatenation here, and that concatenates these two in parallel. So you don't need to do the stack juggling there. How do you know there's 2? Because the arities are known in advance. That's the restriction of this method. You'd have to know the arities in advance.
So the system knows that if you have a multiplier, we're talking about 2 items.
Yes. So the fourth knows that this word has an arity of 2, an input arity of 2, and an output arity of 1. And so it needs to know that. But if you know, yeah, this is not fourth. This is another concatenative language where a semicolon is. This isn't fourth. It's a not fourth, but it's. Yeah, and I would probably use a pipe instead of a semicolon. That would be my character of choice. But naming, I guess, naming fourth words is a personal thing, I guess. But yeah. So as an example, he has this formula, which would be a lot of stack juggling without parallel concatenation, looks like this with parallel concatenation. So it's a lot cleaner, I think. Oops. Yeah, don't know whether it's easy to see on the video, but yeah, just a way of reducing or eliminating, making short work of stack manipulation.
Does look like he knows fourth.
Yeah, I think he does know fourth, but he made his own concatenative language.
He's going one step further. There's an equal sign in there.
Equal sign? Yeah. That's
Swap, do, drop, and read it, all the normal stuff.
Yeah, he has yeah, I don't know what he said you could do everything with swap, dupe, and drop. That's all you need for stack manipulation after that, and then you can create other stack manipulators with that, but I would probably implement that in assembly. And but yeah, I find that parallel concatenation is worthy of consideration. I think it's kind of interesting. Although, oh, San Paulo has a comment.
This actually kind of reminds me of more specialized versions of this concept called under, I think, in factor, and I think cat as well has them.
There's also by.
Yeah. By star. Yeah. Basically, these are operators that do essentially what's being described here, but the arities are assumed in the definitions rather than inferred from the definition of the word itself. If that makes sense. That's a lot of uses of the word definition.
Yeah, the arity comes with the word by, for example, instead of with the word you're operating on.
Right.
Instead of with the data you're operating on.
Correct. Whereas here,
the operators you're operating on.
A single operator, but the arity is inspected. Let's use the word inspected instead of inferred. Basically, the arity of a word is already known in the dictionary, and it just looks it up in the dictionary and does the right thing based on that.
Yeah, but I was trying to implement this in my fourth, and I basically the idea I came up with is to count pushes and pops, but what if you have like key in a loop and you don't know how when the loop will end and stuff like that, so it's kind of I guess that would have to be, I guess it's easiest if you just have fixed arities.
Right.
Yeah, and just have that restriction, which I guess is acceptable, I think. I don't know.
Yeah, I don't see using this in conjunction with a variable length stack.
Yeah. Also, how to implement it on a stack, that's a problem I didn't see at first, but it's how do you, well, I guess you just move the stack pointer, but it is sort of like, I'm not even sure this is a stack-based concatenative language. It may be a tree-based concatenative language. I think he mentioned that earlier in the article from what I remember. It's a tree-based concatenative language similar to Enchilada. Also a tree-based concatenative language. So you could probably do an implicit tree on top of and have it compatible with a stack.
If you know the arities, you should be able to reconstruct the tree.
Yeah, have a stack that also can work as a tree implicitly. That's what I was working on earlier today. And yeah.
Yes, would be quite an elegant solution. And you could also, because it helps with readability, because that's the one thing when I was going through P-threads on G4th, they had some words that, they were weird, they had a lot of punctuation marks in them, and I'm going, what the hell is this thing trying to do?
Juggling and the like, yeah.
Juggling, all that stuff. This would, see, this is string manipulation. You're talking about numeric. No, this is stack manipulation. What am I saying?
Yeah. It's parallel stack manipulation, yeah.
I like that.
Yeah.
And the neat thing about this is you can actually compile this to a register-based architecture like RISC-V or the modern x86-64 architectures that have decent amount of registers. And like the X prime and the Y prime in that example up on the screen there, that can actually be executed in separate pipelines, so that could actually improve instruction throughput significantly over traditional Forth as well.
Yeah, and you could do this you could parallelize this too in hardware.
Well, that's the intent, yeah.
Yeah. All right. Anything else? Oh. Yeah. All right. Cool. Should I turn this off?
Turn it off.
Switch it off for the day.
Oh, well,
yeah,
I suppose we should tell everyone that we're finishing early here. In about 45 minutes. We ran fast. Typical for the time before Fourth Day. We shall see you next month. Remember that it's only 3 weeks until next month. Less than 3 weeks. 20 days. And I don't need to jump up and down. What about November 18th?
It's the third
Is
Saturday
that
of the month.
oh, okay, it's November 18th. What does that have to do with anything? We will see you all then, whenever that then is. Bye.